Hello and welcome to your Math Exam Coach. Today we have another exciting question. This is going to cover some calculations of volume. We're also going to cover some functions. We're also going to do some integration as well. So let's jump into it. The question says the region R is bounded by the graph of x squared equals to y minus 1, where we have x equals to 0, y equals to 2, and x minus 1, x equals to 1. So we need to sketch the region. So here we're trying to we need to plot for x squared equals to y minus 1. But we've seen this quadratic version before. We know of y equals to x squared, and we know the graph of y equals to x squared is a graph that looks like that. But this is 0, this is your y-axis, this is your x-axis. But what we can rewrite this as y equals to x squared plus 1. Here we can draw some similarities between these two. So if y equals to x squared plus 1, and here if y equals to x squared. So here, to go from here to this, we're just adding 1. Right, so for every value of y here, we just add a plus 1. So that's more, that's a translation, right? In this case of plus 1. So we can sketch this graph where we know that our graph is going to look like something like this, where this is 1, 0. We know that then we need another region here of 1. And the point is, this is the x-axis, this is the y-axis. Alright, so let's draw it over here where there's more space. Right, so we already know that we're looking at starting at 0 for y, so we don't need to draw the whole part. So this is the y-axis, this is the x again. So we know that this is 1 because of the, okay, so this region, this is 1, and we know x equals to 1 as well. So this is the region that we are looking for. So let's call that region R. Right, so that's the first part. And then the second part wants us to, when R is rotated completely about the x-axis. So you're rotating about the x-axis. So this region is being rotated about the x-axis. So what do we get from that? So when we are rotating this, this forms the shape of a cylinder, right? So if we are rotating this about the x-axis, it's forming some cylinder. And here, so what we need to calculate the volume, right? We know that the volume of a cylinder is pi r squared times the height, right? So if we go back here, we are rotating about that, and so now what we can write this in terms of this, in terms of y, right? So how do we write that? We can write that as the volume about the x-axis. So I'm gonna call it Vx because we're rotating about the x-axis. Pi. And here I'm going to introduce an integral here of y squared dx. Right. So we're going to take some height dx, which is about the x-axis, right? Because the radius is going to be as a function of y, the radius of the function that we saw in the previous page. So what does that lead us to? We know from the previous slide or previous page, we know that y equals to x squared plus 1, right? So we can rewrite this as, but we also know something about how the bounds of y. So if we go back here, this is the region that would count 0 up to 1. So we know that this is going to be 0 up to 1, and y squared is x squared plus 1 squared dx. Okay, so now we have an integration problem. So here we still have our pi 1 0, and we expand x squared plus 1 squared. That should, if we expand it correctly, that should give us x to the power 4 plus 2x squared plus 1 dx. So now we're looking at a familiar integral, which I'm going to write here. We know when the integral of x to the power n dx, we know that this is xn to the power plus 1 n plus 1 plus some constant. This is how we integrate. So we have pi here. So using this formula, we get x to the 4 plus 1, so 5 over 5 plus we have 2 here, x to the squared, so that's 2 plus 1, 3 over 3 plus the integral of a constant. 1 here is going to be x, and our region is bounded by 1 and 0. So now we just substitute 1 and 0, so we get pi 1 to the power of 5, 1 over 5 plus 2 over 3 plus 1. We don't subtract anything because this is 0, so these are going to be all zeros. So it's like minus 0, which is pi 1 over 5 plus 2 over 3 plus 1, which we can go to pi. We have a common denominator 15 here, 5 times 3, so we have 3 plus 10 plus 15, which gives us 28 pi over 15. So we've calculated the area, the volume of the cylinder that is formed by rotating this region R about the the x-axis. Alright, we come to the end of that question. If you like the content, remember to subscribe and like and also share. We'll be continuing with our series and answering different questions. So stay tuned until we bring the next question. Thank you.